Okay, we're in section 3 of the notes. Again, when you complete studying these notes and you complete the homework in these notes, you should do the web assign and also do something in the discussion group. So what do? We covered section 3, arc length and radian measure. You know, this business over here. We did angular and linear speed. We did area of a sector. We did some small details about some names that are going to be used, you know, acute angle, obtuse angle, complementary, supplementary, what coterminal means. We talked about degree minute seconds, how to convert back and forth between them. And then we went through a bunch of examples. Again, the examples in the blue area, there's answers. Of course, at the whiteboard, I do the work. If for some reason I go too quick during class time, you're more than welcome to watch these embedded videos. The advantage here is that you can slow these videos down or skip them if they just seem to be ridiculous to you, that you can do these things because they're simple questions. Like you might have had this course prior and you already know the material. That's possible. All right, so we went through these examples here. We try to explain the details in these examples so that you're able, once completing this material, that is studying it, understanding what's been presented to you, we're hoping that after you do that, that you're ready to do that supplemental activity, which might mean, you know, going to another textbook, maybe discussing with your friends, maybe go on the internet, doing something to reinforce what you've been taught. All right. So I'm going to claim over here, you should also go through the homework. All right. And certainly when I go through the homework, I'm going to do it on a whiteboard as if I was on a piece of paper doing these problems over here. What's the advantage of this over here? Each question has an answer down. It doesn't have the work though. You're supposed to come up with the work. All right. I'm going to switch to the whiteboard. Just give me 1 second. And I'm going to try to do that. Again, the objective here is not to watch. You should have done this. You may be watching saying, I haven't done it yet, but eventually you want to do it on your own now. Not simply saying, I love watching you do work. That's not going to get you anywhere, by the way. Oops, I don't want to do that. Okay, we're in section 3 of the course notes, and we're doing the homework. Now, I know what someone's going to say. Where did it go? Where did the document go? You have it. We've given this document to you. You have to pay for it. It's there. All right. I'm not going to copy it down. I'm just simply reading it. I'm going to do number 1. And what does it say? It says the minute of the hand on the clock. This is the minute hand, by the way, is 9 inches long. All right. So when I 9 inches long, when I'm talking about the radius of this thing is from its center to its tip is 9 inches long. It says what distance does its tip move in 19 minutes? So this is an S equals R theta problem. All right. Now let me go through this with you. You know, as far as movement, it's 19 out of 60. Unfortunately, what I need to do is get it in the radian measure. So it's 19 out of 60. Again, 19 minutes out of 60 minutes. That's how much it rotated around. But I want to get in radian, so it's going to be 2 pi. All right. This is in radian now. I'm going to write this down, 19 pi, kind of reducing it. And 2 goes into 60 30 times. Right. This is the angle theta. Theta must be in radian. Now, what did they give me? They gave me the R. And what's the R going to be? Well, it's the radius here is going to be 9 inches. What do they want to know? What's the distance the tip move? And that's going to be S. It's going to be arc length now. R is going to be 9. I'll write the unit down later. Times 19 pi over 30. Again, the unit here is going to be inches. I'm going to do some arithmetic over here. Say 3's, 10, and 3 goes into 9 3 times. Now 3 times 19 is 30 and 27, so 57 pi over 10, and that's inch. Put a box in that. No, I'm not going to approximate, but you can if you want. Look at the answer key and see if I got it right. And I'm looking at it, and I'm seeing it. 57 pi over 10 inches. All right, if you want to convert that to, if you want to approximate, you use a calculator to do that. They didn't ask for it, though. Well, let's do number 2. Number 2 looks like a relatively simple question. And I'm glad to have simple questions because it's easy for me to answer the question. What does it say? Determine the quadrant that 245.1 degree lies. Whoops. I went too far with the notation there, didn't I? Let me write that down again for you. So I'm just going to rotate standard position. I start positive x-axis, rotate counterclockwise. That's 90. That would be 180. And this would be 270 over here. Now, where would that be? I mean, I'd have to go more, right? I'd have to go like 60 some odd degrees more. So I'm going to say it's over here somewhere. So this is first quadrant. This is second quadrant. This is third quadrant. So where did it land? It landed in the third quadrant. You can use the Roman numeral or you can use the word third. It's up to you. Look at the key. What do I see over there? I'm seeing the answers, and that's good news. Let me go to number 3. I'll read it to you. It says use your calculator, but show work. It wants to convert this over here. I'll write this down for you. And this is a mixed number. They got degrees, they've got minutes, and they've got seconds. Now what I'm going to do is I'm going to write down what it looks like on my calculator. It's minus 23 plus 39 divided by 60 plus 17 divided by 60 divided by 60. That's like dividing by 3,600. And this would be in degrees. All right. If you do this on a calculator, and again, I want to recommend you do that. Of course, when I go to Sage, I'll show you how to do that in Sage. You're going to approximate. Here comes the deal. How do they want to approximate it? Well, that is, someone's going to say, I don't know how many places you should put down. That's up to you. But right now, I wouldn't go crazy with it. I noticed I didn't specify any level of accuracy there. So I'm just going to do it to 3 decimal places. So I'm going to say about minus 23. That's what that squiggly line over there means. 23.655 degrees. A little box in that. That's 3 decimal places of accuracy. So let's take a look at it. See if I did that right. Yep. And again, when I go to Sage, I'll show you how to do that in Sage as well. All right. So let's keep going. I'm going to go number 4. Looks relatively simple questions. I'm not confused yet. And what does number 4 say? It says, find the radian measure of the central angle of theta of a circle, radius is 70 kilometers. All right. That intercepts an arc length, this is S now, of 156 kilometers. All right. Round your answer to 2 decimal places. So then the question is, how would I do that? Well, there's a relationship here. S equals R theta. What's S? 156 kilometer. What's R? 70 kilometer. What's theta? Well, that's their question. What is theta? Divide both sides by 70 kilometers. And what would you get? I'll write it down for you. Get 156 over 70 is equal to theta. Now, what did they ask for, though? They said round it off, right, to 2 decimal places. So you would need to use a calculator to do that. I shouldn't say, maybe you could do this by, yes, you can do it by hand. It's basically grade school arithmetic. What are you going to get over here? 2.23. All right, that's 2 decimal places. Put a box in this over here. I do want to go through the grade school arithmetic, though. So I really think you should be able to do it. Some people do division differently than me. I'd say in the United States, this is a typical algorithm that's taught. Other parts of the world, they do something that looks backwards to us. Of course, it may look backwards to you, depending where you're from. I always say, when in Rome, try to learn what they're doing, though. Put decimal point down, and I'll add a 0 over here. I'm going to say 2 again. That's 140. I'm going to get over here 20. All right. That's over here. And I'm going to say 2 again. I'm going to go over here. That's 140. I'm going to go here 60. Oh boy. 70 into 600 now. Well, I certainly know it's bigger than 5. Right? I know it's bigger than 5 because 5 times 7 is 35, right? So the thing is, I'm not going to really do it. And what I want to know about that, I really want to know what this digit was. I know this digit here is bigger than 5. I know that much. I don't have to figure it out, by the way. So what does that mean? I have to move up that 2 to a 3. And that's why that's written over there. Let's take a look at the answer key, see if we got it right. And I got it right. That's good news. All right, let's go to number 5, relatively simple questions. All right, relatively simple questions. If you followed along with what we did in lecture. It says find 2 positive angles, 2 negative angles that are coterminal with pi over 3. All right, just going to form a sequence. I want to point out the way to do that. This is radian measure, not because there's a pi there, because there's no symbols about revolution or degrees. So what I'm going to do, pi over 3 plus 2 pi. That's one complete rotation around. What's this going to be? Pi over 3 plus, well, that's going to be 6 pi over 3, right? That's going to give me 7 pi over 3. I want to point out the pattern for going up is going to be 6 pi over 3. Well, that's really easy to do. What are you going to get? Well, we just did it, 7 pi over 3. Now, if you go up another 6 pi over 3, where would you be at? 13 pi over 3. I could do this forever, but they only asked me to get 2 positives. I'm going to say these are 2 good positive coterminals. I want to go in the other direction. What are you going to do? You're going to subtract away 6 pi over 3. Well, if you did that and you went backwards, right? If you're at pi over 3 and you subtract 6 pi over 3, what would you get? Minus 5 pi over 3. Don't worry, you have an answer key to check it in. I'm going to go down again, 6 pi over 3. So what's it going to be? Minus 11 pi over 3. And these are 2 good negative ones. Let me get my little red pen out, see if that's the answer listed. I'm seeing the 7 pi over 3, 13 pi over 3. I'm seeing the minus 5 pi over 3 and the minus 11 over 3. There's an infinite number of other answers. However, we try to stay close. And I really mean that. All right, let's go to number 6 now. It says use your calculator, but show your work. I'm going to go through the work, and I'm actually going to pick up a calculator too. So I'm going to, one of those dinosaur calculators. I'm not going to use Sage, but this is going to be 322.4756 degrees. They want me to write this in degrees, minutes, and seconds. Okay, now what do I know? I know this is over here. Maybe I shouldn't say equal. I say it's approximately equal to. It could be equal, by the way. I'm saying approximate at this stage. It's approximately 322 degrees. Then what do I have to do? I have to take this number over here, and I must convert it to minutes. How do I do that? I'm going to multiply it by 60 minutes are in every 1 degree. All right, I'm going to get my calculator out. I'm going to do that for you. And I'm going to write down not the whole number, but I'm going to write 60 times 475. Wait, you know what? I have a hard time seeing here. 60 times 0.4756. We'll look at the key later. And what do you get? You're going to get 28 point, again, my calculator's dying here, 536. Okay, I'm going to write that down now. 28 minutes. It's approximate. Now, what do I have now? I have 0.536 minutes. And I want to go to seconds. Well, there's going to be 60 seconds in every 1 minute. All right, let's take a look at that. I'm going to do that arithmetic. Times 60. And I'm getting this over here, 32.16. All right. Of course, we tend to use whole numbers. I'm not going to say you can't use a decimal, but I'm going to write down this approximately 32 seconds. Put a box in this. All right. And I'm going to get my red pen out. I'm going to see if I did a good job. I'm seeing this. I'm seeing this. And I'm seeing this. All right, let's go to number 7. A lot of students have a tough time with the reading of these problems. I want to point out reading it. It says on Earth, And there's a footnote over there. And looking at the footnote, it says the Earth is approximately a sphere. All right. And like this over here, with a radius of 6,400 kilometer. All right. It's really not a sphere, by the way, but it says approximate sphere. That's good enough by me. So it says the Earth, there's a satellite circular orbit of 2,600. So I'm going to put this down over here. I'm going to say this is 2,600 kilometers. And there's a satellite over here. What's the satellite doing? It's whizzing around the Earth. It's going around and around and around. All right. So it's whizzing around, and they really do go fast. So like this over here. Yeah, not a great picture, right? So what I'm going to do is talk about what they want to know. I'm looking at it. It says over here, an Earth satellite, circular orbit, 2,600 kilometers above the Earth's surface, makes one revolution every 4 hours. So I'm going to say that's the angular speed of it. I'm going to write that down for you. Use the letter omega for that. And that's one rev every 4 hours. I got to write down, 2 pi though. It actually goes 2 pi every 4 hours. Remember, we need to be in the radian measure, which means pi every 2 hours. All right. So then it says, what's this linear speed? Let's go through this. S equals r theta. I'm going to divide through by t. S over t equals r theta over t. S over t is velocity. I'm going to use the letter v for that, r. And omega over t is angular velocity or speed. All right. Now, what do I know? I know r. This is where some people might get confused. I want to point out that's the r for the satellite. It's 6,400 plus 2,600 kilometers. Push this over here now. All right, that's kilometers. That's the r. What's the omega? This is the omega. So it's going to be pi over 2 hours. What do you get over here? V. 6,400, 2,600 is 9,000 pi kilometer. I'm just reading what I have above the line, 2 hours. What's that going to be? Well, that goes in, 4,500 times, right? Kilometers per hour. Now, what do they want to do? They want to get approximate to that thing. So I'm going to write that down. That's 4,500 times pi. I get 14137.166. Well, I'm just going to round to the nearest whole number because that's what they said to do. Let me put this over here. V is 14137 kilometers per hour. I think you probably realize at this point that's a very fast satellite, and satellites really do whiz by. Let's look at the answer key and see if they've got that, and they do. All right, let's go to number 8 now. I'm going to push this up. And what's number 8 say? It says the area of a sector. Well, let me just remind you, the area of a circle is going to be pi r squared. That's a grade school formula you were given. Now, the area of the sector is going to be theta out of 2 pi parts, area of the circle, theta out of 2 pi parts, pi r squared. This is going to be called the area of the sector. It's a formula derived in class. I notice the pi's cancel out. What do you get? 1/2 theta r squared. All right, let's go back, read the question. It says that the area of the sector is 15 meters squared. I'll write this over here. 1/2, all right? The radius is 3 meters. Well, 3 meters when you square it would give you 9 meters squared. And the question is, what's the angle? Well, we have to solve that. I'm going to divide both sides by meters squared. That's pretty simple. I'm going to multiply both sides by 2. That would give me 30 equals 9 theta. And now I'm going to divide through by 9. And what do you get? 30 over 9. Well, 30 over 9 is 10/3. All right. So certainly, I don't mind the answer. It's a good answer. All right. If you want to write a decimal number down, the decimal number would be, that goes in 3 with 1/3. So 0.33, repeated forever. All right. If you want to put down the degree measure, you can. I notice in my notes, I do put down a degree measure. It's certainly 3.33 is bigger than pi. So I'm expecting a number bigger than 180 degrees. But again, if you're using a calculator, I'll write this down for you. 10/3 times 180 degrees over pi. I'm going to go to a calculator now. And what would that give you? Let me write that down for you. And that would be what? Let me write this down here. I'm going to say 190. And my calculator seems to be dying for some reason. 0.9. You have a really tough time seeing it. 86 degrees. All right, approximately. Again, 10/3 is fine. Let's look at the answer, Kate. See what we got over here. I'm seeing the 10/3. I'm seeing this thing over here. They're approximating that, by the way, and I'm seeing this over here. That looks good. 10/3 is fine now. All right, let's go to number 9. I've been teaching a long time, and I realize a lot of times what happens, you see students write answers down, which really indicates they've really never given it any thought whatsoever about what the answers are. But they want to know what the complement and the supplement of this angle is. And I'll write this one over here for you. So 73.24 minutes, 17 seconds. So I'm going to write the complement down first. And the complement's going to be, if it's possible, by the way, is going to be 90 degrees minus that number. And the supplement is going to be 180 degrees minus that number. Fairly easy to write it down. Question is, can you do the arithmetic? Well, I'm going to do it. I want to tell you what 90 degrees is. 90 degrees is going to be 89 degrees, 60 minutes. It's also going to be 89 degrees, 59 minutes, and 60 seconds. 180 degrees is going to be 179 degrees and 60 minutes. 179 degrees, 60, I'm sorry. I don't want to write it down twice, right? 59 minutes, 60 seconds. Let's do it. Let's write complement down now. That's going to be 89 degrees, 59 minutes, 60 seconds, subtract, that's a mixed number, right? A line over here. Let's see, 17 from 60 is 43. 24 from 59. These are minutes, by the way. That's going to be 5:35. And 73 from 89. That's going to be 6 and 1. All right. I'll look at the key later. Let's put the supplement down. And that's going to be what? 179, 59, 60, minus 73, 24, 17, 43. Not so bad, right? 35. And what do you get over there? I guess 97, right? I say 97. Did I make a mistake somewhere? 73, 180. I wrote 170. That's crazy. I'm looking at it. I wonder why it's really kind of crazy. I think it's like really crazy looking. Put this over here. This is 180, right? What did I write down? 170. What's supposed to be 179? I apologize. Wasn't thinking. Get my eraser out. Okay, sorry about that. We'll look at the key later, by the way. And what do you get over there? I guess you get 106, right? 3 from 9 is 6, 7 from 7 is 9. Yeah, looks good. Look over here. Supplement, complement. Let's look at the answers, see if we got it. So we got 16, 35, 43. I'm glad about that. 106, 35, 43. Looking good. All right, let's go to number 10. And what's number 10 say? Find the area of the sector. Let me remind you, I think we've done this before. The area of the sector is going to be 1/2 theta r squared. I want to repeat this to you. Theta must be in radian measure. So what do they say? Find the area of the sector. They tell me the theta is 50 degrees. I need to convert that immediately. That's pi over 180 degrees. And what's that going to be? That's going to be 5 pi over 18. Let's see if I did that right. Yeah, I think I did. All right, 5 pi over 18. We'll check the answer later. It says the diameter. I don't want diameter, I want radius. Well, the radius is going to be half of the diameter. So the radius is going to be half of that diameter, which is going to be 5 meters. Or again, the diameter is 10, the radius is half that number, 3.5. What do they want to do? They want me to come up with the area of the sector. So the area of the sector is going to be 1/2 times the theta, that's 5 pi over 18. That has no unit on it, by the way, times, well, what's r squared? 25 metered squared. Let's see if I can do that. And I'm going to say it really doesn't look bad. 5 times 25 is 125 pi metered squared. And you get 36 at the bottom. Let me just read it to you. It says that I should approximate it. And again, find the area, round the answer to the nearest hundredth. So I need to do that now. And again, I'm going to use one of those dinosaur calculators. I'm going to put it on times pi divided by 36. And I get 10. I'm having a tough time seeing my calculator. Looks about 0.91 nearest hundredth metered squared. A little box in that. I'm going to go to my answer key. I'm going to look at it. And I'm hoping I got the same answer. Let's take a look at it. Yeah, I got it right over there. Let's go to number 11. And number 11 is the last question. Relatively simple set of problems. If you study, by the way, if you haven't studied, nothing can be simple to you. So what's 11? The circular blade of a saw has a diameter of 6 inches. So I'm going to say the circular saw has a radius of 3 inches. Okay. And it rotates. This is going to be the angular speed at 5,400 revolutions per minute. Okay, I'm going to convert that to the radian measure. All right, so I get a 1 rev, 2 pi. All right, and I'm going to write this down. Angular. Let's see, 5,400 would be 10,800, right? Times 2. And revs cancel, and I get pi per minute. Okay, so let's read it. It says the circular blade of a saw has a diameter 6 inches and rotates at 5,400 revolutions per minute. I got another problem over here because the first question is on the angular speed of the blade in radians per second. Well, I got to take minutes and go to seconds now. So every 1 minute has 60 seconds in it. That's pretty simple. Well, minutes cancel off. And what do you get? I'll write this down. My angular doesn't look so good there. My omega doesn't look good. Let me erase it again. Let's see, you get 1080 over 6. Minutes cancel off per second. I'm going to reduce that. And I think 6 goes into, well, you know what? I forgot the pi. I'm sorry about that. I think 6 goes into 1080. Let me put this over here for you. 1080 by 6. I'll do 2 first. That's 540 over 3. I'm going to do 3 into 54, or 540, I'm sorry. 1, 3, 24, 8. So it's 180 pi per second. Okay. So I got the linear speed down there. If you want to approximate, you can. I don't think they really, certainly I'm looking at the key. It isn't a K. Use a calculator if you want to do that 180 times pi. And you're going to get 565.487 is in the K. I'm going to put a box this over here. This is A. All right, let's go to B. B says this. Find the linear speed of the saw in feet per second. Oh, this is going to be interesting. So let me write that down for you. And S equals R theta. If you divide by T, you get V equals R omega. All right. Now here comes my problem over here. They want to know what V is. What's R is 3 inches. But they want me to convert this to feet. Well, there's 12 inches in every 1 foot. And what's the angular speed? Well, it's 180 pi per second. All right. And they want this in feet per second. Well, let me see if I can do that. I'm kind of looking at it. It doesn't look bad to me, to be honest with you. I'm going to say 3 goes into 3 once, goes into 12 4 times, right? Hope you can realize that. Pretty simple, right? And what do you get? 4 into 180. That would be 45, right? So what's V going to be? 45 pi feet per second. All right. So I'm going to put a box in this over here. I'm going to look at the answer key now. I know they approximated, by the way. You can do that too. And I'm seeing the 45 pi, and this is in feet per seconds. I'm going to go to Sage. Switch to the boards now. Let me open my terminal. I run Sage from a terminal. You can do this co-calc on the website sagemath.org. If you want to use different software, please use whatever software you're comfortable with. The reason we're trying to push Sage here, it's free. Being free, everyone has access to it, right? And you can run it on just about any computer there is, including tablets. I even think it can run on a cell phone, all right? Now, certainly I don't recommend running it on a cell phone or a tablet. I recommend getting things on a computer. But anyway, I'm going to go look at the Sage code, and I'm going to do reset. Let me see. I noticed that. You know what? I have to correct my notes. It's reset, and it's a function. I got to correct my notes over there, and I'm going to do some arithmetic over here. Now, so I wonder where that arithmetic is coming from. It's coming from the notes, right? So I want to go back over that. Make sure you know that all this stuff over here is coming from the notes. So let me go back in the notes. And a lot of this stuff just really comes from what we're doing over here. That's that thing over here. All right, let me do this one over here. 23 plus 39 divided by 60 plus 17. Now remember, I said 3,600. Well, that's like dividing by 60 and 60. That's 3,600. If you do this, you're going to get a number that, for a lot of students, doesn't make any sense. They actually just did the arithmetic. But if you want to get this thing to be in, decimal number, what you need to do is just insert a decimal somewhere. I just typed a decimal in. Hit return. You're going to get to 23 point. Wow, it's a long number there. You have to learn how to round it though. All right. So again, going back over the notes, things are relatively simple. The number pi on a calculator, at least on this calculator, is just pi. If you want to approximate pi, what you're going to do is, whoops, let's do that again. Sorry about that. That's an approximation of pi. All right. You can do it to very arbitrary precision. I'm not going to worry so much about the arguments at this point, but I'm going to put in something here which might seem outrageous to you. Whoops, overflow. Yeah, it's too much. Let's see what's happening here. You might have a tough time coming in with the server too, though. I'm not saying that it can't do it. It's computing pi out to a very large number of digits, by the way. I'm gonna have to kill the operation if it doesn't go. Again, the server might be reacting funny to this. All right, I had to kill it. Let me do another one. There you go. Someone says, why didn't I put 100 digits down? It's something to do with a binary thing. Don't worry about it. You get a lot of precision of these things here. You can read up on the function n if you want. But anyway, that covers about it. Really not much to say about that over there. I do want to point out and look at the notes. In the notes, if you want to type this stuff in, you can. You might learn from that. I'm hoping you do learn from that. All right. If you want to go to Wolfram Alpha, you can also do that. Whatever you're comfortable with, use your calculator, whatever you're comfortable doing. All right. Good luck to you.